With Rancher, it's very easy to create Kubernetes clusters. Welcome to a fast introduction to Rancher. My name is Ivan Lausuk, engineer at SUSE. The first thing to do is to create one or more node templates. A node template is a predefined configuration that Rancher will use to create nodes. Usually we create one template for masters and other for workers, because each type needs different resources. For instance, for workers, maybe we need more CPU and memory. To do that, in the top corner, we have a menu with the option Node Templates. I have to predefine, but let's create a new one with the button Add Template. And the first thing to do is to select which provider we are going to use and configure the access. We have different options here, for instance, the region, the image to use, and the most important, the size of the machine. In this case will be 4 GB memory machine. And we can pre-attach this virtual machine to a network I created previously, and this is interesting. And finally, we have to put the name, my master, for instance. And there are other options that could be interesting, for instance, to configure insecure registries or registry monitors or engine environments, something like that. And click on Create, and we can see that here. Once we have our templates, we come back to the clusters, and let's create a new one with that cluster. First of all, we have to select the cloud provider and put the name of the cluster, my cluster. Then we have to create node pools for each kind of node. Usually we'll have two, masters and workers. Let's create the masters with 3 masters to ensure HA, and we can select the previously template created, my master. Then we have to choose which kind of services is going to have. In this case, the etc, and it's going to put in green here. That is, it's okay. We have what we need to create an etcd database, and the control panel, and it's going to be in green. We create a new node pool for workers, and we select 3, for instance, and the template for workers, and select this is a worker. With taints, we can create different kind of workers for this different kind of works or jobs. For instance, we can create different templates for workers. For instance, if we need one worker with a huge amount of memory because it's going to allow pods that needs a lot of memory, we are going to taint. This is a label. We are going to taint the different workers with different taints, and with Kubernetes we are going to select the preference of this pod to be in this kind of worker on the other kind of worker. But we can add as many node pools as we need. The second thing to do is to select here a kind of Kubernetes version. The last one is the default, and the network provider. In my case, I'm going to select the default one, network isolation available. We can select isolation or not. We are not going to explain that now, but we have this option. In this case, the cloud provider, it's interesting because some cloud provider needs to configure external load balancers. So we can choose what option of this we need. About the private registry, for instance, if we are using the SUSE private registry, we have to enable that, put the URL and the user and password for use that directly. And in the advanced options, we have the option to pre-install the Nginx Ingress. Is the system to have external access to this cluster, for instance, for serving pages. We can choose metric server monitoring in this case. And something interesting is to create a snapshot of the database of Kubernetes for in a local directories or in S3 of Amazon. And then we can create the cluster. Once the new worker is created, we can see it here. We can see how the number of clusters of the resources of the cluster has increased. Now also we can access to it, and we can see how it already have a certain number of pods. It usually are the system pods. We can do more operations on that. For instance, cordon. That means that Kubernetes is not going to allocate new pods on this worker, or drain. That Kubernetes is going to move out of this worker all the pods, for instance, for maintenance operations. We can also delete that. That means that it's going to rebuild all the worker. It's not going to remove the worker. It's only to rebuild all the worker. And to remove workers, we have to select that we want 3 workers instead of 4. And it's going to remove this worker. Okay. Also, some interesting is that we can launch the kubectl from here. And we can see all the pods we have. And also, something is really more interesting than that is to have the kubectl configuration in our terminal. So to do that, we can select here. We have here the configuration. We can copy that and paste into the .kube-config. And it's going to allow us to access to the cluster. Kubernetes also allows us to list the persistent volume we have in our cluster. This is the list. We can select one of them, and we can see the capacity, and that is bound to one of the pods, and the persistent volume that claim this persistent volume. Also, Kubernetes Rancher allows us to create namespaces. A namespace is to create Kubernetes clusters, virtual Kubernetes clusters inside the Kubernetes cluster we have created. To do that, we can add a namespace, put a name, and we can select a project where we be created. And something really important is that we can limit the CPU and the memory of this namespace, for instance, to not affect the others. One example could be, for instance, if we create a testing namespace that we don't want to affect to the production namespace. We can limit the CPU and the memory, and it's going to Kubernetes is going to restrict this namespace to this environment. Also, we can create a project. A project are groups of namespaces. It's introduced by Rancher and allows us to do some operation directly in a group of namespaces. Rancher also provides a dashboard that is a replacement for the kubectl using a UI. In this button, try dashboard. We are going first of all to see the same, the CPU usage, the memory, the pod. This is the summary of the cluster and the recent events. We also can see the nodes. We have the nodes here with the CPU and RAM. We can access to each of one to see what happened here, for instance, the events and other things, the resources. We can access to the namespace and create namespace from here. We can select that. We can choose a namespace, for instance, and access to the YAML to create this namespace. And we can access to the workload that are the list of deployments and stateful sets we have here, for instance. Let's go to RabbitMQ, and we have the number, the pods that it composes this deployment, and we can see in which node is each of one. Also, we can create a new deployment. Is the substitute of the entire configuration of deployment using YAML. We can put the name, the type, the image, the ports that are exposed to the rest of the pods of the cluster, the command to access, the working dir, and add some environment variables, the resources to limit the memory and CPU, the health checks, and other things. Also, we can list here the number of the list of pods. But something interesting are the config maps, for instance, the secrets and the services. For instance, we can access one of the services, and we have here the listeners, and the selectors to choose the pods that are going to be served with this service, and we can extract the YAML from this service. And we have other systems, other options like network policies and airbag information about how to access to these clusters. For instance, with roles, I created this role, GitLab Runner 0, and we can see how which operations can be created from here. And we can see also the storage, which are the volume attachments with all the information. We can select one of them, and we have information here about the YAML of that. The storage classes, in this case I only have one, but we can create different ones to allow to create our volumes in different kind of environments. For instance, in DCVs for Amazon or Cinder or something like that. And that's all from this part. Let's back to Rancher. Rancher also allows us to manage the applications we have installed in our cluster. To do that, let's go to the section applications. And first of all, we can activate some of the catalogs we are going to use. For this demo, I have these three activated. And then launch an application. For instance, MariaDB. It's going to create the variables YAML for the Helm chart. And first of all, we put the name, MariaDB, and the target projects. In this case, will be the default, because I don't want anything in the system. It's here. And also we can configure different aspects of the Helm options, and some settings for the MariaDB. For instance, the database user and password, and other things. How Maria is going to be replicated, and if we are going to enable the persistent volume for the slaves, and how will be the service. In this case, a node port is enough. and we can override other variables, for instance, for production, are recommended variables for a production environment, and then launch, and it's going to create a MariaDB environment. It's installing now and deploying. After a while, we can see that it's activated. This MariaDB is activated, and we can do some Helm operations like upgrade or rollback. Let's go to see how this MariaDB is in our dashboard. Let's go to the dashboard. Let's go to the workload, and we can see that we have several activated stateful sets in a MariaDB namespace. It's interesting that we can access to the stateful set master, and we can see one of them running. We can go to the MariaDB slave, and we can see here two of them running. And this is the end of this demo. And you have questions, you can contact to me. Thank you very much for your attention.